Hello, this is Jeremy Hong from Hong's Electronics, back with another video. This will now be 1.5 out of 3 videos based on a Twitter comment that I got that the video was much more tell than show, so we're going to rectify the situation by doing basically kind of like a live demo here. So I'm going to record this live at least. Once again, this unit was provided by Digilent. They are sponsoring this video series. Let's see. I guess the plan here is just to do some like basic circuits first, and then I don't know, make some measurements, kind of guide through that, right? Just kind of the whole walkthrough experience on like some of the basics for. I'm thinking first circuits 1, where it's just like let's start with the very basic fundamental of Ohm's law probably, and then I don't know, go from there, kind of just pick and choose some random use cases that I could think of from courses that I've done over the years. This is going to be kind of interesting because, again, I'm going to do this live, and so I might have to edit out some portions, and then, you know, breadboard will magically appear here, or, you know, the parts and stuff. So anyways, I had to think about it for a moment, but when I was like, okay, one, where's my where's like one of my many breadboards? So I'm gonna pick this nice little breadboard combo here, where you have an Arduino Uno underneath here, and then this half-size breadboard should be enough for what I'm trying to demonstrate here. And then we also got 2 of these analog devices parts kits. I believe one of these, I'm trying to remember if, I don't think these were sold by Digilent, but they had something very similar, and so I do not have those original ones, so I'm gonna have to rely on these 2 for now. But I mean, basic point is like, right, I have, you know, R's, L's, and some C's here and there scattered about, right? So resistors, inductors, capacitors, and then we're going to put that all together and see how it works, right? So yep, again, another kit down here, and yeah, so this one actually has even like a DC-DC converter, which is kind of nice because again, we can kind of demo all those things as we go along here, and then hopefully I don't make any mistakes live, although only shows how authentic this video is going to be, right? All right, so now I need to first find actually some power supply cables or such, or let me see. I know I put some here. Let's see. All right, so I will plug in. Let's try plugging in the multimeter here. So we'll put that, make sure that's ready. Okay. I got at least one scope probe over there. Ouch, that just poked me. Let's see. Okay. Now. Yeah, so we will make sure we have this ready to go. All right, so that we'll put aside here. All right, I did order those actually, so I do have those somewhere here. I think we have everything we need. Okay, let's make sure this is plugged into the waveform generator in advance. Okay, here we go. Okay, so first thing we're gonna do is definitely let's do Ohm's law live, right? Let's try that. How hard could it be? We will pick. Actually, let's do a 1K ohm resistor. I do like 1K ohm resistors a lot. Okay, let's put that into somewhere in the middle of the breadboard here. Actually, let's do that, and then let me remove this guy here. Okay, so okay, so now what we're gonna do is, oh yeah, basically, okay, let's just do this. Right, just resistor, power supply. Okay, kids. let's see what happens when we apply 1 volt first, and then I don't think I have the current limit. Okay. So let's see what happens. Now we're looking at voltage and current here. Oh, you just have to delete these. Okay, let's do that. Okay, so you can see here, again, we got 1 volt going in, so that's this yellow axis, or yeah, yellow. And then, okay, so scaling is, yeah, 1 milliamp range. So, right, 1 volt, 1 k ohm resistor, you're gonna get about a milliamp. It's, yeah, we got some noise on here, so one way we could resolve that is, let's increase the voltage, shall we? So 5 volts, 5 milliamps. Okay, we can see all that live here. And then, let's see, is this resistor getting hot or anything? No, I shouldn't. Okay, yeah. Okay, cool, so that works. So now we can then be like, oh, let's measure this with the multimeter. So we're in volts mode. Let's do the classic, just measure a voltage here. Oh wow, look at that, 4.990 volts. So there is definitely some drop across the cables here, so we can probably see that here. Oh, whoops, I'm measuring, I just realized, across this way. Look, yeah, there we go. So yeah, we're definitely getting a bit of a drop across the cables, which is fine as long as we can explain that in a lab report, so to speak, right? So there's that. Okay, so now, yep, again, you're seeing this live. So yeah, it's kind of cool to see how I don't know, I mean, the ammeter is definitely accurate, of course, live, but it's really fast at updating, relatively speaking, for a power supply. And kind of demonstrates the point that, oh, okay, yeah, I'm giving 5 volts out, and then getting a current draw of 5 milliamps, and so, right, that works out to resistance of 1 k ohms, right, if you solve for R in Ohm's law. And that all makes sense. Everything makes sense in the universe here. We didn't break any laws of physics. So now, okay, let's add another one in the series, so we can turn off the power supply. And then, right, so we'll just add another one. So now we have, right, 2 k ohms, right, in series. And so what's our current draw going to be? Oh yeah, that's right, we're going to be at like 2.5 milliamps basically. I mean, with some noise, that's going to be plus minus a range here. I noticed that since this current readout on the actual like power supply readout we have on this panel rounds up, it'll actually, oh, okay, yeah, there you go. It's swinging from, yeah, what was it, 2 milliamps to 3 milliamps. So it's somewhere in between, right? Like, you know, we're at 2.5 on paper for this. And so now, okay, what if we put this in parallel, right? So let's do that. Put that here. Enable. All right, yep, so right, well, we have an equivalent resistance of, what, 500 ohms right now, so yeah, our current draw is right at 10 milliamps now. Yeah, at least the voltmeter on this, or this voltmeter and ammeter on the panel here is showing 10 milliamps exactly. So yeah, one other thing we can demonstrate again is, right, we can go back here. We can show voltage drop, right? Wow, 2.5. Wow, 2.5 when you round that up. It's amazing how this works. So now, okay, let's try this measurement where, okay, we'll do parallel, and then we'll put the ammeter from here to here, right? So it'll be in series from this 1K resistor in this parallel path, and then we shall see how that works. So we should be, what is it? I'm trying to remember what the ratings are on this. I think we should be fine. 100 milliamps max. Oh yeah, we are. Yeah, that's right. We are fine. Okay, let's try now. Measuring current, shall we? Oh wow, would you look at that? It's 5 milliamps. So there you go. There's like, I don't know, maybe like the first two or 3 weeks of lab, right, when you're doing resistor combos and series and stuff, and in parallel. So let's turn that off. Okay, so now let's do some fun stuff. Okay, so let me put this back here. We're gonna do RLC in series with an oscillator. Let's see, trying to remember my resistor code here. Oh, okay, that one should be 100. Okay, there we go. And again, right, like we have a full featured DMM here. So I can, if I'm not sure about whether or not this resistor is actually what it is, because again, it's, these are, I don't even remember, I think these are like maybe like 1/8 of a watt, so these are a bit smaller. Yep, so that's 100 ohms. Okay, it's close to it. It's for the demonstration here. Let's bend the leads. Let's do or L. All right, so let's see, I'm gonna have to remember where that position is. Yep, and then C. So, okay, now we will put SIGGEN across here, and then we will observe, no, yeah, plug in the scope probe here. We will see how this looks. Let's see. So right now, we don't need supplies right now. We don't need the DMM. We're just going to go into scope. We're going to go into wave gen. Let's see. We can actually, I believe, just split this window, right? Okay, there we go. So yeah, we only have one waveform generator channel on here, so that's all good. Okay, all the scope channels are turned off. Okay, we got 1 volt amplitude going in. Let's just run this. Okay, cool. So, what do we see here at first? Okay, so one off the bat already, I'm already seeing quite a bit of loss, right? We can keep those measurements here by doing this from the panel. I am very, very used to doing this. So we can do it for that. Let's see. Frequency, vertical, let's see. Let's do peak to peak. Yeah, so our peak to peak should be, it should be at 2 volts, right? Because again, measuring from here to here, that's a full 2 volts of peak to peak. But let's see, just to make things easier, let's put amplitude in there, just for things to be easier to look at, and then close. Okay. Right, so we see this, we're like, okay, what's going on? So what happens if we increase frequency? It's like, whoa, wait a second, is this some sort of filter in a way? Right, and so actually, right, that gets into a point where it's like, oh, okay, we see this in the scope. Now we can go into your network analyzer, basically. Let's make a full screen for this. And yeah, we can start from 1 kilohertz to 1 megahertz, do an amplitude of 1 volt. We can run it. Let's see. Yep, okay, cool, cool, cool. Oh, I should disable the other channels. That's fine. And it's like, wow, look at that. We already see quite a bit of... Right, so we definitely saw it where earlier, right, with the default like 1 kilohertz, we were like barely making the full amplitude that we were putting in. So let's see. I think we can go up to like 20 with this. So here, let's see what happens. Okay, cool. If I recall, let's see. Yep, this is fine. Oh yeah, we don't really need phase, so we can just keep it to that. So yeah, the question is, was this consistent from earlier, from what we saw? I think so. Let's see. Yeah, this seems correct, because right, we saw an amplitude increase at one point from when we were looking at the scope. Oh, whoops, I did not mean to do that. So we'll just stop. We'll separate, actually, we'll make the separate window. Okay, run all, run. So what did we see earlier? What happened when we went up to... Yeah, so we never quite reached... What was that? It was at 2 megahertz that we at least get back to the full 1. So I'm wondering, oh, I wonder if by default this is going into 50 ohms because nope, it's 1 mega ohm. Okay, cool. And yeah, we're using a 10x probe. Oh, there we go. Yeah, that's better. Okay. That is more consistent. Oh, yep, and there you go. There's... Wow, that just works. Yeah, we saw this behavior earlier right here, right about, what was it, like, yeah, meg to like 2 meg is when we saw it really get back to its full amplitude. So that's kind of cool to see that, right? Let's go, oh wait, so Windows, yeah, here we go. So we could demonstrate that again here. Yeah, because we're reaching just here, it's right, it's just getting back to 2 volts peak to peak. Amplitude's not really fully back, at least from what it is measuring. Oh wait, so you're telling me that this is basically a high-pass filter of sorts? Wow, that's kind of cool. What if I told you you could apply this to like all sorts of like audio circuits, and then, you know, this is kind of like the beginning of like getting into linear systems, right? It's like, wow, that's kind of cool. So yeah, that's just like right off the bat, I did already from scope, wavegen to scope measurements, just right manually putting those, dialing those in, and then going to then actually going to the Bodhi plot or the network analyzer function, right, and actually seeing that behavior plotted, right, the amplitude response, frequency response, basically, right, just sweeping, and then seeing that, yeah, right after about a megahertz, we really start to see it, a nice return to the full amplitude. You made this filter, where is the 3 dB point, right? And it's like, oh, if you just kind of eyeball it, you could just say, oh, that's fine, like, you know, right here, or, oh no. Oh man, the joys of using a trackpad on this computer. Okay, there you go. Oh, dang it. There we go. Yep, you see that. Yep, okay, yeah, so that's basically your 3 dB point that you marked. Yeah, so we basically demoed the analog channels for the scope, waveform generator, the multimeter, and then the power supplies, right? So again, right, circuits 1, you're basically just using all 4 of those instruments, basically, the entire lab, right? And so that's just kind of how that goes. Yeah, so basically, right, at least with like passive networks and stuff from like circuits 1, and then maybe even going into linear systems and such, right, you got all that covered. Yeah, so right, you can do all sorts of like interesting audio circuits with this, of course. Kind of, I don't know, I've at least loved learning circuits via that kind of feedback, right, audio feedback or such, right. That's just a personal preference of mine, because again, I love noisemaker circuits. We got the beep. Hold on a second. Why are we? There you go. Let's see. Let's put these back. Now, what can we do? Oh, okay, yeah, some obvious things. So, what if we have like a light dependent resistor, right? That although I never really learned formally these in class, like, right? I mean, I think maybe we covered it in sensors, but let's put that here. Yeah, let's use the multimeter function here. So I don't know, like, right, you're like in a robotics course, you use this as a sensor, right? Or your senior design uses light dependent resistors as part of its project, right? Let's see. Okay, let's go back in ohms mode, right? Okay, cool. Now, so the nice thing is, right, we have the trend plotter or the trend logger, right? So now we can actually record how this resistance changes over time, right? So it's like, wow, look at that. Yeah, so it's gonna auto scale. Yep, there you go. Okay. Whoa, it's skyrocketed. It's like open. And then, woo, okay. Yeah, so kind of a cool demo of like, right, oh, here's like a basic sensor essentially. Yeah, so let's say, for example, right, you're now in a linear systems course, which again, at least in my school doesn't have a lab, but we can, let's see, we can clear the bench here for a bit. Let's put these here. So right, you're in your linear systems course, you're learning about what, like your FIR, IRR filters, right? Finite impulse response filters, right? Or if I add a math channel, or yeah, software filter. So let's oh whoops, let's do this first. Actually, oh, that's right, I do need the waveform generator. So we're gonna insert. Alright, so let's go scope. We want scope. Okay, so now we're going to do this where we're gonna have a sine wave that we're feeding in. Let's see. Oh yeah, let's change the scaling on this. Oh yeah, we're back to 1x. So right, yeah, 1 volt amplitude, And then we have a filter that we're adding in. Let's see. Okay, actually let's put this SigGen on the side here. So right, we're doing this. What kind of filter is this? It's a low pass filter at with a cutoff of 10 kilohertz. So right, you can already see that, yeah, the filtered signal is quite attenuated by this point, but what if we do this? Oh wow, it's getting larger. Oh wow. Okay, so now let's change the scaling on this. This should have been the same scale. Okay, there you go. Wow, look at that. And then let's see. What if we do like a 12th order filter? Oh heck yeah. Yep, so that's when it starts to do that. So yeah, let's do a high pass filter. There we go. Yep, maybe see that line up. So yeah, again, right, like you can see, right, you can do Chebyshev, Butterworth out of the box. Oh yeah, there you go. There's your FIR coefficients, right, for a custom filter. So you got all that in here. So right, like that is kind of the neat thing is, right, you're actually putting in a real signal into a system here. Let's do the example with the square wave, right, where let's do a low pass. So right, the classic example of, okay, what if I'm putting in a 10 kilohertz signal and then my square wave is right at, or my filter is at least right at 10 kilohertz. It's like, oh, interesting. I only see the sine or like the frequency component really there, right? The that's kind of neat. Let's see what we can do. Do that, or we could do see that. Okay, there you go. So that's actually kind of cool to see that where let's see, specifically with high pass, where there's a point where you only, yeah, you see isolate the high frequency component there, and it's like, oh wow, there's stuff like into the megahertz range. Oh, that's right. So that's kind of neat to actually see that. Where is, okay, going back to low pass, right, everything's attenuated. It's like, right, you see the actual fundamental frequency, and then, right, you kind of see this reconstruction of the square wave essentially happen, right, which is like, oh, wow, look at that. It's like the Fourier series is happening, right? So actually, what I'm kind of curious to see is, oh, whoops, can we do an FFT? Okay, cool, yeah, we see this. So, right, let's see what's going on here. Yeah, okay, we're at the same volts per division. So, how I'm interpreting this right now is, right, since this is just the clean, or like, not the clean, but like the direct input signal, right, we have all the components of this square wave going in, and right, and then like, right, with the low pass filter, we're filtering out lots of those high frequency components. If we put up the cutoff frequency higher, we start to see that we get all those back until we have our fully restored, unfiltered square wave, which is kind of cool. Yeah, it's like, wow, okay, that just works. So right, like I almost want to say that, right, great. The thing with like linear systems or some of those more like abstract math-based courses, right, or at least like there's no like lab components. I guess what I'm trying to say is right, having like these visualizations definitely helps put into context, like, oh, okay, right, you know, what's like, right, a square wave is really made out of, right, all these it's the sum of all these sinusoids, right, and right, that's why you learn Fourier, and then eventually, right, then you kind of see this in action with like filters, right, where it's like, oh, I'm filtering out, you know, all the components of the square wave after the certain frequency if I do this like low pass filter, right? And it's like, it's actually kind of cool to see that actually in the frequency domain, where it's like you see that see all the loss toward the bottom here, and right, you start to see that the square wave, right, is not really is starting to not be square anymore, right? It's becoming more of a sinusoid. Eventually, it's like, oh, whoa. It's like, wow, that's kind of cool. Okay, so right, it's like, wow, you have like a nice self-contained linear systems lab in here, right? Let's see, going back here, what did we miss? Yeah, so, yeah, I mean, logic analyzer is pretty self-explanatory, right? If you're used to the waveform software, this is basically just the same as all of them. And then, right, again, it's just you have the sheer number of channels on this guy is like massive, right? Like it's 34, because right, it's 32, and then you get 2 dedicated clock pins, which I'm pretty sure they're still just signal pins, but yeah, it's that capability in a scope in this price range does not exist. So that's definitely what makes it unique, and then definitely bridges the gap between like an academic product and a professional product, because there are certainly use cases, at least I have use cases for, you know, reverse engineering hardware where I need that many logic analyzer channels. Right, like, you know, you can have, oh, let's see, let's do this where, let's add all these. Yep, and you see, it's like, wow, look at that. It's actually kind of overwhelming to see this. And then, right, like, you know, you can set all these to decode, right, whatever protocol. It's kind of neat, and then, yeah, that's at least somewhat self-explanatory in my opinion, at least. But yeah, it's yeah, hopefully this at least answers some questions about, like, right, just basically like the basic workflow, right, and then just how to navigate the UI. It's, again, I almost regret I don't have to sell it to myself, because right, I'm used to this with the right, so I have the right Analog Discovery 3 currently, also use this a lot, and yeah, right, it's just becoming really used to it, and then there's not really any other alternative to this, and yeah, that's all I can say. So hopefully everyone enjoyed the video. I'm gonna do, again, 2 more of these. Possibly I'm gonna try to integrate more demos, because right, again, my apologies for making show and tell more tell than show. Yeah, that's on me. I kind of got carried away with editing last night, and then completely forgot that I had to add the whole show component of, like, oh yeah, here we, you know, let's plug in some circuits, right, and then let's see, let's get up and running, right. So yeah, anyways, I'll try to do that in the next few videos, which I'll try to film here quickly. And again, hope you enjoy the video. Thanks for watching.